For this particular problem, we can see that this is a geometric series. 1/2 is that R value. R is less than 1. So because the first the question is how do we write these answers? So I know that our B sub K, our B series converges. So this isn't pretty, but I'll jot the answer over here. So the series B sub K from K equals 1 to infinity converges by the geometric series test. So the original series K equals 1 to infinity of A sub K converges by the comparison test. Sorry, there's not quite a space for those. I didn't plan ahead there. So if the larger series, if the new series that you make is larger, and you can prove that the new one converges, you can tell me that the original one converges as well. This feels weird. It's only one example. Try a few more of these and you'll get the hang of it. As opposed to the next piece, which is the comparison test for divergence. This time, if 0 is less than C, which is less than A for all of K, and if C diverges, then A also diverges. There was a question in class, do we have to call it C? It's just your other B. They're just trying to get this one separate from the other picture. So in this case, here's my A sub K, whatever it looks like. And C sub K is the new one that we're making. So I'll pop that down here. If I can show that C is less than A, and I can show that C diverges, A has no choice but to diverge by that comparison test. All right, so example 2, show that the series below diverges. So we need something to compare it to. And you're not going to pull things out of thin air, but it should be somewhat related to what you started with. So what you'll do is you'll take the highest power in the numerator, which is K, the first power, and the highest power in the denominator. If I distribute these two K's, this will be K squared. So this simplifies to K equals 1 to infinity of 1 over K. Now, this, if I look at it, I know that this diverges. What did we call it? We initially called it harmonic. And then last lesson, we said that this would diverge by the p-test and also the integral test. Any of those are valid reasons, but most of the time you'll see folks refer to it as the p-test as a good reason why it diverges, or the harmonic series. So the next thing we want to do is we want to compare A and B, or A and C in this case. So if I have K plus 3 over K, well, let's do it this way, K plus 2, and I'll compare it to 1 over K. What the textbook does, maybe this makes sense, is 1 over K times K plus 3 over K plus 2. You know, how do these two things compare to the 1 over K? Well, the first part's the same, but then this fraction, you're always multiplied by something larger than 1, K plus 3 over K plus 2. As you go to infinity, it will get closer and closer and closer to 1, but it will always be a value larger than 1. So because of that, the term on the left is bigger. So 1 over K, K plus 3 over K plus 2 is greater than 1 over K. So 1 over K is the smaller one. Great. We've proven that. Check. We said that the smaller one diverges by the p-test. Check. So how do we put all of this together? And again, that's the tough part. Do we have to write all of this out? You need to have enough to be able to show what test you used. So for this one, I might say, K, 1 over K is less than or equal to, but it is less than 1 over K times K plus 3 over K plus 2. Okay, so I've established that it's smaller. Then I can say that K equals 1 to infinity of 1 over K diverges by the p-test. Therefore, my original K equals 1 to infinity of K plus 3 over K times K plus 2 must diverge by the comparison test. Okay, there you go. So if your new series is larger and you can show that it converges, then the original series has to converge. If your new series is smaller and you can show that it diverges, the new series or the original series has to diverge. What you can't say is this: if this is my original series and this is my new series, if I say that the new series converges and it's smaller and it converges, it tells me nothing about the larger series. The larger series could converge, the larger series could diverge. If I say my new series is larger and I say my new series diverges, right, it goes up here, then I know nothing about the original series. It could also diverge, but it could converge. So you want to make sure that whatever you're comparing is either pushing it up to diverge or collapsing it down to converge. Collapsing it down to converge. I know, diverge and converge start to sound the same. So sometimes we can't always compare. In that situation that I just told you, this limit comparison test can help us out there. Suppose we have A of K and B of K are both series of positive terms. We have 3 different possibilities. If we take the limit as this approaches infinity and we get a number, just has to be a number that's not 0. Both series will converge or both series will diverge. And this will depend on the new one. Depends on B. Whatever B of K does, A of K will do the same. The second situation is if you get a 0, and if B converges, then A also converges. It doesn't say anything about diverge. This works for converge only. And the third situation you get is if you get infinity and B diverges, then you can say that A diverges, but you can't say anything about converging. So you want to be really careful with these definitions because there are very small details that differentiate between one rule and another. So example 3, determine whether the series below converges or diverges. So again, what are we going to compare this to? So here's our B's of K. Again, I would take the highest powers. So this is K to the first over K squared. And this becomes K equals 1 to infinity, 1 over K. We keep talking about this one. Does this converge or diverge? We know that this diverges. It's harmonic, the p-test, and that's integral test. For all of those reasons, we know that that diverges. Now, if we compare sizes here, okay, let's compare how we did in the last one. So I've got K plus 1. I'm going to do a 1 over K in the front. Here's my K plus 2. How does this compare to 1 over K? As you get closer and closer to infinity, this K plus 1 over K plus 2 does become almost 1, right? Infinity plus 1 over infinity plus 2 is infinity over infinity. We could use L'Hopital. We could say that that's equal to 1. However, when we're at the lower values, say we put a 2 in for that K, 2 plus 1 is 3 over 2 plus 2 is 4. So you're multiplying by 3/4. You're multiplying by a value that is smaller than 1. So therefore, the piece on the left is less than the piece on the right. Just the opposite of what we had before. So in this case, okay, 1 over K, that's the B series that we're going to compare to. That 1 over K diverges. So it's bigger and it diverges. That is not enough information to directly compare to the original. We can't compare it to A sub n. So what are we going to do from here? this is where we use the limit comparison test. So let me see if I can write this a little bit nicer in here. This will be the limit as k approaches infinity, or n approaches infinity. I keep writing them back and forth, of k plus 1 over k times k plus 2 all over the B series that we just made as 1 over k. If I use infinity right now, I've got 0 over 0, that's indeterminate, lots of other things. So how do we clean this up? You're going to multiply by the reciprocal. So I've got k plus 1 over k times k plus 2 times k over 1. What happens next? This k in the numerator cancels with this k. And now I know if I put infinity in, this is infinity over infinity, but L'Hopital tells me I get a 1. So that takes me to situation number 1. The limit as n approaches infinity of a sub n over b sub n equals L equals a non-zero number and also non-infinity. And both series either converge or diverge. Well, because B diverges, we can now say A diverges by the limit comparison test. So we'll say k equals 1 to infinity of k plus 1 over k plus 2 diverges by limit comparison. And now would be a good time to look at those flow charts that I gave you and the tables. How does the terminology, how do the definitions in those tables match with what we have in our notes? They all mean the same thing, but sometimes just it can be written ever so slightly differently. Example 4, same idea. Determine whether the series below converges or diverges. Compare with a P series. So now they're telling us exactly what to compare to. Before you jump into this problem, I have a typo. This K should not exist. I apologize to my 8A class. I made a big mess of that with that K there, so that should not exist. So what are we going to compare it to? Again, we're going to keep the highest exponent. So K equals 1 to infinity. I'm going to call this 1 over 2 k to 3 over 2. Now, the 2 coefficient, you can take it or leave it. A lot of times with series, we only care about the exponents. We don't want anything else. So I believe the textbook just compares it to 1 over k to the 3 over 2. I'll leave the 2 there because when we did limits initially, we would have left the 2 there. But being as you're not looking for the answer, you're just looking for an answer as opposed to the exact answer, the 2 can stay or go. It doesn't matter. It won't change anything. So if we come back to this, we now have a P series where P is equal to 3 over 2. Because P is greater than 1, we know that this series will converge. Okay, so now we have to compare. Is it possible to use a direct comparison? If I have 1 over 2 k 3 over 2 plus 5, if I compare that to 1 over 2 k 3 over 2, the term on the left, because you add 5 in the denominator, let me think about this, will always be a little bit smaller because the denominator is greater. And actually, I think you can just use a direct comparison test on this. But if the new one converges and it's larger, then the original must converge. But let's do limit comparison. That's what we're supposed to be learning here. So you say the limit as k approaches infinity, 1 over 2 k 3 over 2 plus 5, 1 over 2 k 3 over 2. We know that this would be 0 over 0. So I'm going to multiply by the reciprocal instead of going to L'Hopital. So k approaches infinity. This is 2k to the 3 over 2 over 2k to the 3 over 2 plus 5. This is infinity over infinity. This is where L'Hopital would be appropriate. We'd find the derivatives of k's. They would cancel out with the 2's. We're left with 1. This takes us back to that first situation. that either both series converge or both series diverge. Well, we said that the one that we're comparing to, the B series, is convergent by the p-test. So therefore, this is also convergent. So say k equals 1 to infinity, 1 over 2k to the 3 over 2 plus 5 converges by limit comparison. I know I mentioned this in another lesson, use the fact that the homework problems are on that specific topic only. Use that to your advantage. If you know that everything in section 10.4 is comparison and limit comparison, then only use those tests. When we get to 10.7, they're all going to be mixed together like alphabet soup. But for now, they're all very separate. Example 5, one more here. Determine whether the series below converges or diverges. Compare with a P series. I'm going to compare it to k equals 1 to infinity. I'm going to go with 3 root k over k to the 3 over 2. So it's really square root of k, square root of k, square root of k. This will simplify. This equals k equals 1 to infinity. You'll be left with the k in the bottom. This is harmonic, this diverges. That 3 doesn't matter, but this diverges by the harmonic series. We know we're doing limit comparison. I'll jump right in. K approaches infinity. This big thing. Okay. So I have the A series over the B series. It's really, if I put infinity in right now, it would be 0 over 0. Instead of jumping into L'Hopital derivatives, I am going to multiply by the reciprocal. It's the first way to simplify this. Let's see, at this point, I have infinity over infinity. You can use L'Hopital. You can look at those exponents, but you'll be left with a k to the 3 over 2 in the numerator. And in the denominator, a 3, that coefficient, and k to 3 over 2. Basically, everything else is insignificant. The +2, the +1, the 3k squared, those are all insignificant. So this becomes fun. Again, we're back to that situation on the top that if you get a numeric answer for the limit comparison test, both will converge or both will diverge depending on what that original one does. Or not the original, depending on what the B series does. So the B series diverges. So now we can say that the A series, that original one, also diverges. Here we go, diverging by the limit comparison test. All right, I have one more example for you. Instead of comparing to the P series, we can now compare to a geometric series. If you take a peek at the bottom of the page, those are just some examples. Geometric, harmonic, P series, and the series K to the K. Right? So determine whether the series below converges or diverges. What are we going to compare it to? Again, you're taking those highest exponents. This would be 2 to the K over 3 to the K. And I know that this would be 2/3 to the K. This is geometric. And R is equal to 2/3. 2/3 is less than 1. So I know that this converges. If we're using limit comparison, we'll jump right in. We'll say the limit as K approaches infinity, 2 to the K over 3K plus 5 over, I'm going to go back to this version, 2 to the K over 3 to the K. This is all kinds of infinity over infinity over infinity over infinity. This is really crazy. So we'll say the limit is k approaches infinity. 2 to the k over 3 to the k plus 5 times 3 to the k over 2 to the k. All of these things are going to cancel out. So the limit as k approaches infinity of 3 to the k over 3 to the k plus 5. Right now it's infinity over infinity. You can use L'Hopital and you will wind up with it for 1. So that takes us to the first situation, and that whatever the B series does, the A series will do as well. So in this case, the B series converges. We can say that the series k equals 1 to infinity, 2 to the k over 3 to the k plus 5 converges by limit comparison. So part of writing out those tests is getting yourself comfortable with them. When they all get mixed together, are you going to have to say which test you use? Probably not. Some of them have more than one test. The end goal is knowing whether it converges or diverges. And so a lot of times these show up in multiple choice questions with the Roman numerals. If you look at the AP practice problems in your textbook, you've had a few of those so far where there's 3 series and it says which ones converge, which ones diverge. Oh, it's only 2 and 3. Oh, it's 1 and 3. So you just want to make sure that you're well versed with all of the tests. Keep working on them. This is section 10.4. For this school year, 10.4 will count for the 4th quarter, and everything from here on out is for quarter 4. So keep working at these, asking questions when they come up. Reminder, these are just some of the tests that you can compare to for the comparison tests, and the limit comparison test. And then these are all of the series that we've talked about so far. The test of convergence, geometric, P-series, integral test, direct comparisons today, limit comparisons today. Alternating series will be our next lesson. And then right after that is the ratio test and limit test. So keep working, ask me questions. We'll see you in class.